Hi friends, next we are going to see the second experiment. As I told you, we are going to continue. This second experiment is the automatic actuation of double acting cylinder using 5x2 pilot operated valve. So we are going to actuate a double acting cylinder using a 5x2 pilot operator. So, and it's also going to be done automatically. That is only after we are going to give the supply of air, the piston is going to actuate automatically unless we are going to stop the supply of air, right? So I will now explain the component that we are going to use for this experiment, and then I will make the connections and I will tell you how it is working. Right now, again, like previous experiment, we are going to use a FRL unit. Again, the incoming air has to be filtered, regulated and lubricated. So that is why this FRL unit is used here. Incoming air has to be filtered, regulated and lubricated, because the internal parts of these structures might get damaged because of the dry air that is coming inside and the dust particle that is going to carry. So that we are going to filter, regulate and lubricate. So regulating, as I told you in the previous experiment, regulating is very important because the incoming air is at a high pressure, so it has to be maintained to a certain level. So you can monitor the pressure of the incoming air through this pressure gauge, and it also can be adjusted with the help of the knob that is available on the top of this FRL unit. So we have a knob available at the top of this FRL unit. So with the help of this knob, we can adjust the pressure, incoming pressure. If you need high pressure, we can use it. And it also, there is a range of pressure that is available is from 0 to 10 bars. So 0 to 10 bar, you can vary the pressure to any extent. So we cannot go beyond the 10 bar, and the component that is available here cannot withstand up to 10 bar. It can withstand the pressure of around 3 bars to a certain extent. So we have to clearly maintain the pressure in order to get a long life for this kind of components. So this is a trainer kit, whereas when you go to industries like big structure of machine are operated with the help of pneumatic. So those are all the places where you will be having the valves of bigger sizes. So it is going to be very precisely operating machines like CNC machines that has to move precisely to one place to the other place. The spindle head has to move precisely to the cutting area. The spindle which is carrying the cutting tool, it has to move to the workpiece precisely, and it has to make the cut or whatever operation that is going to do, it has to be done very precisely. So that is where the component has to be very clearly maintained. The internal structure should be very clearly maintained. So that is where this FRL unit is very important. So we are supposed to filter it before we are going to send the air inside. Filter, regulated and lubricated. So this system is playing a very major role for each and every activity, right? The next that we are going to use is this 5x2 double pilot valve. So what is it 5x2 double pilot valve is? Like as I told you, I'm going to explain it now. So 5x2 double pilot valve. Double pilot valve is, as I already told that, the numerator always indicates 5 ports, the number of ports. Numerator always indicates number of ports. Denominator always indicates the number of position that is going to take, that is going to shift. Because the valve is going to shift from one position to the other position in order to transfer the air from one point to the other point. So this is having 2 positions, so such that it is going to transfer the air in 2 different directions. So we are having 5 ports, out of which so 3 is input and output, input come output, and 2 is exhaust. So out of 5 ports, 3 is input and output port and 2 is the exhaust port. As everybody had an experience of traveling in MTC bus or other private buses, where you have an automatically actuated doors. Whenever there is an opening of door and close, there you can hear a sound of gush from the system. That is simply the air is getting lit outside through the exhaust. We cannot maintain the entire air inside the system. That obviously there should be an opening to send out the air, because the air that is sent into the system, it cannot get stuck within the system. Only when the air is sent outside to the other way, the air can enter through the next way. Because the air, when the air is getting blocked on the other side, we cannot send the air to the next side. So the air that is available on the other side, it has to be sent out. So that is a possibility that is available in case of double acting cylinder. So double acting cylinder is not the kind which is available with respect to the single acting cylinder. Single acting cylinder had a spring inside. When you are going to supply the air, after removing the air, obviously the spring will move back the piston to its original position. But with this double acting cylinder, it is not possible. So you have to send the air on one side, so that the air on the other side has to be sent out through the exhaust. The same thing happens. When you are sending to the other side, the left hand side will get the air through the exhaust. So out of the 5 ports, 3 are the input and output port, and the 2 are the exhaust port. So that is the structure available here. So this is the 5x2 pilot operated valve. I will tell you, I will draw the structure here. I will draw the same structure here. So this is how that is available. So you have and then see, this is 1, 2, 3, 4 and 5. You have 5 ports. So you have 1 input, 2 outputs. This input, these 2 are outputs, and these 2 are exhaust. 4 and 5 is exhaust, through which the air is sent outside. And these 2 are the positions, 2 positions. So you will be having a spool inside, spool available inside, that will be having a channels, channels cut through the spools. This spool is moved with the help of the air supply that is supplied here. This position 1 and position 2. Whenever this position 1 gets the air, the spool will move to the right side. And whenever you get the air through this second position, the spool will move to the left side. The movement of the spool will adjust the air to either this output or this output. So air is supplied in through this input. It has to get outside of this, either of the port, either second port or third port. That is done with the help of the pilot action that is done by the position 1 and position 2. There are multiple number of valves available, like lever operated valve, spring operated valve, and then pedal operated valve. This is pilot operated valve, and you are also having solenoid operated valve. Solenoid operated valve is, it is operated with the help of electricity. Now we are having a pilot operated valve. Pilot in the sense, air is a medium that is going to operate the entire valve. So air itself is acting as a medium, whereas in solenoid operated valve, the electrical supply will actuate the movement of the spool that is available within the valve. This is a spool available within the valve that is going to direct the air pressure from the input to the output. Whereas here, the air is taken as a medium and it is sent inside the valve in order to actuate the spool, right? So this is what done here. Now next, coming to the next components, we are having the double acting cylinder available here. So double acting cylinder, it has two limit switches, this one and this one. These two limit switches are kind of switch which is actuated. It has got a name called as roller spool valve. It is roller spool valve. It has a knob available here. So actually whenever the piston retracts or moves forward, I am simply manually doing the action. So whenever the piston is moving forward and retracted backwards, it is going to press this knob. See, if I am going to move the knob, piston backwards, the knob is pressed. This is roller, it contains the roller. So if you can see this, there is a roller available here. So there is a roller available. So that is why it is called as roller spool valve. Now when the piston moves forward, it again presses the knob topwards and it channels the air to the position 1 and position 2. So this limit switch will change the position of the output ports 1 and 2. Whenever we are going to give the input here, air supply, it is going to give the output through this two ports. That is maintained by these two roller spool valve. So forward stroke and return stroke is actually done with the help of this limit switch. This only changes the direction of the air supply that is given to the double acting cylinder. So I hope I have given enough information about the components that we are going to use for this entire experiment. Now we are going to give the connections and we are going to see how it is going to get actuated. Okay? So now I am going to make the connection. So already I have taken the output from the FRL unit and given it to the manifold. Now from the manifold we need 3 outputs. I am going to make all the 3 outputs. There is, so one output is going to go to the roller spool valve, that is limit switch 1. And the limit switch 1's output, that is the input I have given from the manifold. I have given the input to this roller spool valve, that is otherwise called as the limit switch. I have taken the output from the limit switch and I am going to give to the position 1. So this is the position 1 and this position 2. So one limit switch is utilized for activating position 1. Now I am going to use this limit switch to activate the position 2. So I am going to use the second output and I am going to give it to the second limit switch. And I am going to take the output from the second limit switch. I am going to give it to the second push. See, I have taken one input from the manifold and given to the limit switch 1 and taken the output from the limit switch 1 and given to the position 1 and they taken second output from the manifold and given to the input of the second limit switch and taken output from the second limit switch and given to the input of the second position input. So these are all the two positions. Whenever the air is sent through this, the spool will be actuated to either direction in order to get the output from either port 2 or port 3. The port 1. 3 and 4 is the exhaust. So you have one exhaust here, another one exhaust here. So whenever there is piston movement forward, the air that is available on the front side, it will be exhausted through one of the exhausts. And whenever the piston is going to retract, the air available on the other side is going to get exhausted on the other exhaust. So this is how it is going to get operated, right? So now the connection is not done entirely. Now we are going to give the supply to the, we are going to give the input to the 5/2 bias operated valve. Because these 3 ports are the one that is going to actuate the cylinder. So we have to give, they are supposed to give the input to the cylinder. Now I am going to make the connections. So I need one more output from the manifold. So I am going to utilize this one. So remove the knob and then take the output from the manifold. So give it to the input of 5/2 valve. and take the output from the 5/2 valve. So parallel connection has to be made. You can also make the crisscross connection. I'm going to make the parallel connection. So left hand side to the left hand side of the piston, the right hand side to the right hand side of the piston. So we can make the crisscross connection also. Only thing that the forward stroke and the return stroke will get exchanged. The forward stroke and the return stroke will get exchanged. So you can make the crisscross connection also. I have made the parallel connection. Now all the connections are done. Check whether the entire system is locked. There should not be any other manifold port that is left open, because if you lock in the air supply from the FRL unit, if any one of the manifold is open, the air will get escape through the manifold's opening. So you have to check entirely whether the system is completely closed loop. The entire system is to be completely closed loop. There should not be any opening, right? So once again we will run through the connection, the FRL unit to the manifold. From the manifold I have taken 3 inputs. One input is going for, I have taken 3 outputs. One output is going for the roller spool valves input. Roller spool valves output is going to be given for the position 1 of the 5/2 pilot operated valve. And then I have taken the second output from the manifold and given to the roller spool valve of that is second limit switch input, and then that output is taken to the second position. And then I have taken third output from the manifold and given it to the 5/2 pilot operated valves first port, that is input port, and then taken both the output port from the 5/2 pilot operated valve and given it to the cylinders both directions, that is forward stroke or the return stroke. Now we are going to look at how this pilot operated 5/2 valve is going to actuate your cylinder automatically. Now when I give an air supply, the piston has to move forward and backward automatically. I'm not going to do it manually like previously when I did it with the bare hand. I'm not going to do that. I'm going to just give the air supply and see that the piston is going to get actuated automatically. That is forward stroke and return stroke is going to get actuated automatically, right? So now the entire connection has been made and I'm going to give the air supply. So when you're going to give the air supply, the piston is going to get actuated automatically. So until we are going to stop the air supply, the piston will automatically actuate continuously. It is done with the help of this 2 roller spool valve. You can see it very clearly. I will give a close-up kind of activity and I will explain what is happening there. So the actuation will be quite noisy. When I explain what is happening, you might not hear it. I will be quite louder. Please bear with me. Now I'm going to give the air supply. So now the piston is getting actuated. As you can see that,
you have 2 roller spool valves. So both the roller spool valves moved upward and downwards in order to change the
air direction to this position 1 and position 2. So one limit switch will activate this position 1 and the second limit switch will activate the position 2. So by this way, the air is being shifted to one side and the other side with the help of both the positions. The air supply is given to the either side of the. So by this way, by moving this roller spool valve, there is a limit switch. The air is being shifted from one position to the other position. The air supply is given to this 5/2, that is all the time in actuated condition. Only thing that whether it has to come via this port or this port, that is going to decide the movement of your piston either to the forward direction or to the reverse direction. So this roller spool valve will make that action. So when the air supply is given to the position 1, it is going to move the spool to the either to the right side or the left side. that will bring the air outside this ports and give it to the cylinder's opposite ends. That is either side of the ends in order to actuate the piston. So this experiment clearly shows that how we are actuating a double acting cylinder automatically using a 5x2 pilot operated valve. So in this session we have covered two experiments. One is verification of logic gates, AND gate and OR gate with the help of a 3x2 pilot operated valve and a single acting cylinder. And then we saw a second experiment called as automatic actuation of double acting cylinder using 5x2 pilot operated valve. So I hope that these two experiments would have clearly given you some idea about how these actuators are used in the mechatronic system. Even though what to say that we didn't use any computer parts here or an electronics parts here or a control system parts here, which are all very mandatory for the mechatronic system. But still, we understood this how this mechanical part of actuators is getting actuated with the help of the pneumatic system. By incorporating various sensors like thermal sensors and then light sensors and the pressure sensor, we can limit the pressure, etc., to this entire system and make this actuation to our requirement. Now I am going to slightly make a change in this system and I am going to explain you how we can control the actuation of this double acting cylinder, automatic actuation as per our requirement. If I want to reduce the actuation of the forward stroke, that is the slowness, that is now the forward stroke and the return stroke is happening at the faster rate, very faster rate, that uncontrollable nature. I am going to use a flow control valve in between and I am going to reduce the flow on either direction. I will show initially for the forward stroke and then I will show it for the return stroke. What is it is, we are going to use a flow control valve that is available here. You can see that this is a flow control valve. You have a knob available here at the top. Whenever you are going to adjust this knob on the top, it is going to control the air supply that is going to be given to the cylinder. So what I am going to do is I am going to use this flow control valve and adjust the air supply that is given to the cylinder. Now this is your return stroke. I am going to give it via this flow control valve. See, I have taken this return strokes air supply and I am going to give it via this flow control valve. So one end I have connected it and the other end we are going to give it to the cylinders others. Now if you look at it, I have given it via flow control valve. What I am going to do is, see, you can clearly see the change of stroke that is happening. So what I am going to do is I am going to adjust this knob and show you how the stroke is getting slowed down. So you have clearly seen that how the flow is controlled on one side by adjusting the knob by using the flow control valve. With this kind of incorporation into the system, we can make multiple number of changes. So that is where mechatronic systems comes in handy. Like it can be a flexible one. It can be made into different kind of structure as per our requirement. Now I am going to make, I am going to use one more flow control valve and I am going to adjust the return stroke also, that is forward stroke also. What I am going to do is, I am going to take the supply, I am going to give it to the other flow control valve and then I am going to give it to the other end. Now what we can do is, we can adjust both the strokes at a time. previously I adjusted the return stroke by using the flow control valve. Now I am going to use another flow control valve and adjust both the strokes. I am going to give the air supply now and see how both the strokes are adjusted. See? So one flow control valve. Now the other flow control valve is also used. So previously I used one side to control, now I use both the sides of using the flow control, I control both the actions. So this is how you can incorporate a new kind of circuit in order to change as per our requirement. So previously it was automatically actuating. Now also it is automatically actuating, but to our expectation. Previously I could not control the forward stroke and return stroke. It was continuously going as per its own rate. So there is no change that is happening in the forward stroke or the return stroke. So I wanted to make some action to be slowed down. Whether I am going to push something like you might have seen in packaging industry where the product is pushed on one side in order to bottle it or box it, wrapping it. Like those kind of activity are to be done in a different rates, different speed. So in order to make that kind of speed adjustment, this is where the flow control valve comes in handy. So this is only the manual, that is basic pneumatic trainer kit where you had a basic idea how a pneumatic system is operated with the help of ASM. So you can incorporate sensors and control system inside the system in order to make a different kind of entirely structured mechatronics oriented system. So in upcoming lab classes, we can see other experiments where you are supposed to, where you can see new sensors and control system, microcontrollers. Using that, how you are going to entirely operate a real-time environment. Like you can adjust this entire room's temperature by having a temperature sensor. Or you might have seen the traffic control system where the traffic control is done with the help of changing the lights, green, orange and red. That is automatically done with the help of and microcontroller only. So those are all an example of mechatronic system. So this is very beginning level. We can incorporate other structures and bring a real-time mechatronic system in the future classes. So in the future classes we will see other experiments so that when I complete this lab course, we will be able to understand the entire mechatronic system. So thank you, and we will meet in the next lab class. Thank you.